Hello everyone, good evening. Am I audible? Can you guys see my screen? Can I get some response in chat box? Good evening all. Good evening and welcome to day 7 where we are going to learn about convolution neural network. So in day 7 we will be discussing about CNNs, which is used for image based tasks, because our session is moving towards we want to achieve AI with image, which is with computer vision, so we will be moving towards it. Good evening all, very good evening, and thank you for the response. I hope I am audible and I hope you guys can see my screen, right? Good evening all. Am I audible? Can you guys post some emojis in chat box? Good evening. Yeah, so we have our Jetson Nano ready and we will be going with it now. So we have to first learn about convolution neural network. We have already seen about CNNs. We have already seen about neural networks. Today we will be discussing about convolution neural networks and tasks with it. Okay, so we will be learning how to implement in both the PyTorch as well as TensorFlow, and that will mark the end of today's class. So the topics today we will be seeing about convolution neural network majorly. And before going into that, I just want to get some response that yesterday we have seen about one topic. Can you guys remember what it is and post what it is and what all the topics covered in our previous class in chat box? Yes. What is the topic we have discussed in the previous class? I think we have went with connecting SSH, and then we went with the neural network creation, how to create simple neural network with PyTorch as well as TensorFlow. That's what we have discussed in the previous session, right? So which do you prefer, PyTorch or TensorFlow? Which do you find convenient? So we'll be going either one for each of the projects, okay? So actually the next session is going to be day 8 will be projects, where we will be discussing about traffic sign detection using convolution neural network. So I think earlier we have just went with the Iris dataset yesterday, which is a sample text tabular dataset. Fine. Today we will be learning about the neural network, which is very powerful, which can handle image data actually. So we will be learning about convolution neural network, CNN. Also in short form it is called as CNN. Great, thanks for the response in chat box. Many have entered PyTorch and TensorFlow. TensorFlow is the majority people are preferring, right? Anyway, so what is the CNN? First let us learn the maths and the understanding behind CNN, then we proceed further. So CNN use a unique architecture with convolutional layers, okay, that allow them to learn local patterns and features from the input data, and pooling layers that reduce the spatial dimensionality of the feature. This may be not understandable, but let me explain and make it work now. So this makes CNN well suited for tasks like image processing, image classification, object detection, image segmentation, and so on. So this is what happens in a CNN. Actually, when you have image based data, okay, when your data is of image format, you have to actually go through a series of steps to integrate in our neural network. Actually, images are nothing but multiple color channel of pixel values, which is going to be matrix, which I will be showing now. Anyway, so you have an input image. Here I have an input image, and I have a fully connection, which is called as the feature learning part. This is the CNN parts, convolutional layers. It has multiple layers. I will be explaining what it is. So once we process it, we go through a mandatory layer called as flatten. And after that we go into our fully connected layer. Remember, our fully connected layer, this part, okay, is going to be the same dense layer or the ANN. Okay, so this is ANN, this is another set we add just to process the image data. So together they call as CNN. Okay, so when you look at the image, particularly image data, image is nothing but pixel values which ranges between 0 to 255. So there are two types. One is black and white or grayscale image, which has only one color channel. The 0 goes for black and white goes for 255 goes for white colored pixel value. So if you stack it, okay, for red color, for green and blue, so you have three components with varied variety, or the intensity will be changing, okay, on each. So when you overlap all these three, you will be able to get a colored image, which is a combination of BGR, blue, green and red. And when you combine based on the pixel intensity on each of this particular layer, okay, on these three, what is the particular pixel will determine what the output color will be, okay, on the finally what is the color of your image will be seen, we will be able to see it. So are we clear with this? What's the difference between black and white and RGB image? If we are clear, then we could learn about the convolution operation. So that's actually an image, particularly here. For example, as you could see, this is an input image, which is, it's a multi-class classification between horse or zebra or dog. Okay, so you know this fully connected layer, this is your artificial neural network. Okay, you interconnect, you make the weight and bias, the same process will happen here. But okay, here finally we have three neurons which will determine the probability, like we did with the yesterday's class on iris dataset. But before this we have this flattened layer, and before that we have some set of feature mapping extraction part, which is a convolution operation. So the convolution operation goes like this. It has a convolution layer and then it has a ReLU activation function. So another convolution layer, ReLU. So in between we have some pooling operations going on. What all these things if we understand, then we can understand the entire working of CNN. So can we start with this? Can we start with the convolution layer now? So that particular patch, right, we have seen lot of things going on here. So what this happens in this one thing is what we are going to learn now. So this, your input image has been processed by a convolution plus ReLU. And let us learn what happened there now. So coming into here, what is this convolution operation? Okay, so as you could see, I have my input image. Consider that it is of shape of 6 cross 6 cross 3. Okay, so this is the shape of my image. 6 cross 6 cross 3 is the shape of my image. I have three color channel. Okay, 1, 2 and 3. Three color channel images are there. RGB image. Okay, so 6 cross 6 is the matrix shape of each pixel. It's a 6 cross 6 pixel. Okay, so this is my image. So what happens especially here is, this is the entire convolution layer operation. Finally ReLU is applied, as you could see. But before that, let us understand one by one. So first step, there is something known as kernel, also called as filter, will be applied. Okay, so consider that you have a filter, you will be deciding the shape of it. Let me go with the shape of 3 cross 3. So this matrix kernel is having a shape of 3 cross 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. It is just randomly assigned values. Okay, so these values will be randomly assigned, like your weight and bias. So what this kernel will do is, it will first take a patch of your image, this patch, the similar shape. Okay, so this is 3 cross 3, it will take another 3 cross 3 from here, take it out. Okay, perform dot product multiplication. So both dot product multiplication will be happening, and the output will be stored here. Okay, so the result you could see, it is 31. So everything will be multiplied and then finally summed together to get 31. Fine. Now next what happens, this filter is used to extract the feature from the image, because it goes and collects some information. So the kernel is a matrix that moves over the input data. Okay, perform dot product with the subregion of the data and gets the output as the matrix of dot product. Now from here, okay, so from here what happens is, you calculated this, right? Next it has to move step by step to calculate and get a final output like this matrix. So it has calculated this, it has to fill all these parts. So how it is actually doing is, it will move. Okay, so in general by default it is called as stride, with a value of 1 is the default one. So after, as you could see, this is the red color patch, right? Once that has been done, it will move one step next. Okay, so it has this green color patch. Okay, so it will take this, then one step next, it will move the next part, so it will fill this value, then it goes below and take this patch, okay, to fill this value. So then this patch, to fill the middle value. Like that it will complete to get the output. So this is default of stride with 1. You could also adjust the stride value when you build the neural network CNN. So if you go with stride 2, then it moves 2 steps. Once this red patch is completed, it will move 2 step next and take the green patch, then comes 2 step bottom and take this blue patch, and so on. So this is stride. As you could see, step by step this will move, perform dot product, fill the value, so it gets the output. So this is the filter or kernel operation with stride. Also, as you could see, my image is of shape of, what's the shape of this image? It's a 6x6 matrix with 3 color channel. This also will have 3 channel behind. Same operation will be done. So as you could see, my input image is of 6x6. Okay, I take 3x3 filter and I am performing dot product multiplication, obtaining output. Okay, so this will be done, and once it has been completed, the output is actually, now can you guys post what's the shape of this output matrix totally? What's the shape of it? Can you guys post down what's the shape of the output matrix? It is 4x4, right? As you could see here, we are extracting information, but the features information is lost in the corners. Okay, when they found in the research that this size reduction here especially leading to loss of features on the corner. So what they did is they give you an optional, by default it won't have, you could also we already have for deep learning. You could check our particular website, sorry about it. You can go and check our LMS platform. We have deep learning 1 month internship from basic. Again, it will be dealt with lot of projects. Or if you want from the scratch, you could go for machine learning, that will build the base. And if you purchase this internship, we will provide the machine learning basics as well. So as you could see in the corners, okay, you could optionally add this padding. So if you go with padding, you will be adding either zeros or the same values as in the corners. So you add a dummy additional layer to save the information presented in the corners. Okay, so this will help you to save the information in the corners, and when you perform the matrix multiplication, now the output is still 6x6. So this is done to save or preserve the information at the corners. So padding 1 layer can be done, padding 2 layer can also be done. So once you are completed with this, okay, we know the ReLU activation function is done. Okay, so when you apply ReLU, what happens? All the negative will be converted to 0 and positive will be taken as such, because the formula of ReLU is 0 comma max, or max of 0 comma x, which is the maximum one that will be taken into account. Okay, so that will help you to take ReLU out of it. So when you perform ReLU, you get output. Okay, then bias gets added and the output will be generated. To avoid zero error, we go by adding a bias and then output will be generated. So are we clear with this one single convolution operation? Can I get some response in chat box? Can you guys post down some response quickly, guys? Waiting for your response. Are we clear with one convolution operation? And guys, you can convert this masterclass into 1 month certified internship on NVIDIA with AI. So when you join, you will be getting all 30-day recorded sessions, 30 days of PPT, 10 exclusive project codes, VIP community group for doubts and internship updates, IETE internship confirmation letter, 90 days of LMS course access, assignments and tasks, weekly live sessions, resume building, mock tests, and internship and participation certificate will be provided for you. So once you join the internship, we will be getting all these benefits from our side, and the fee is a discounted fee at 999. It's a limited time offer. The batch 2 ends on 27th by this weekend. So if you guys are interested, you could still get on the batch 2 and continue this entire internship. You can go with batch 2. Okay, you could join and get all these benefits. The link has been posted in chat box, available in description. If you guys are interested, you could make use of it and still join the batch 2. Batch 2 ends by this weekend. So I think this process is completed. So this one single convolution operation is completed now. So after convolution operation, we go with pooling layers, okay, to reduce the feature dimensionality. So for doing that, there are multiple options, most preferably we go with max pooling layer. So after every convolution operation we go with a pooling layer, and that we go with max pooling in common. So what is max pooling? In max pooling layer we go with a filter size. Okay, so let me go with 2 cross 2 and stride off 2 cross 2 in general. So if I have a 4 cross 4 matrix like this, okay, so it splits based on the filter. Okay, so it splits into this part, into this part, into this part, into this part. So this pooling layer is maximum pooling, which means out of this patch it is going to take, okay, it is going to take maximum in these each block. So here 9 is the maximum, so that is taken. In this green box 7 is the maximum, that is taken. Here 8 is the maximum, that is taken, and here 6 is the maximum, that is taken. So like this the patch will be taken. So what you are actually doing is you perform this convolution operation, you reduce, you extract the features, and then you perform feature dimensionality reduction here by performing max pooling. Okay, so max pooling layer will be helpful for you to get the important information alone to be picked. So once this is done, you get an output. Okay, after that if you want, you could stack more layers like this. You could have another convolution layer which perform that input, it will get perform the same operation and produces output. So you can go with another max pooling. If you want, you can have multiple convolution and max pooling layer like this. So if you want, I'll show you a demo. There are particularly some famous networks, for example ResNet architecture. I'll go with the image. Okay, so you could see they perform, there are some additional layers actually. You could go convolution, then ReLU layer, then max pool, then this block, okay, it is repeated again. So they will be going for multiple blocks like this. Okay, for example, let us open it in. So as you could see, 3 cross 3 convolution layer, 64 neurons, like that they add. Okay, they have convolution layer, pooling layers. Okay, Rajesh, there is actually formula for it. We can do it actually using the formula. Let me show you when we go for PyTorch. Okay, are we clear with this? Yeah, so you could stack like this. Okay, so you would be going and adding layers, finally you stacked, but the problem is once you get output. Okay, so now the thing is, see here, you gone with convolution plus ReLU pooling layer, convolution plus ReLU pooling layer, convolution plus ReLU pooling layer. Okay, so finally you have output which is of 3 cross 3 shape. The shape will be like this. You will be having 3 color channel, so it is having 3 layers. The thing is, if you wanted to connect to your fully connected layer for further processing to make prediction and perform back propagation and make it the entire workflow, your output should be of 2 dimension or normal, like your elongated data. Okay, but this is of 3 color channel which can't be taken by our neural network. They can't work. They can work with 1D data. So how to do this process conversion? So when you want to convert, okay, all your output from convolution layer to your fully connected layer, you go with a mandatory layer called as flattening. So you take a particular image pixel, a particular single layer will be elongated like this when you perform flattening. 110, 422, 021, flattened, right? Then if you have 3 color channel, what happens is 3 here, I have 3 color channel, so this will be elongated like this. Then this will be elongated, this will be elongated, everything flattened to a single dimension layer. So this is done. This flattening is must. This is the connection between your convolution operation and your fully connected layer. Once this has been connected, then you could go for your usual layers, like your fully connected layer, go with some dense layers. Okay, so once you do it, you will be configuring with optimizers, activation functions and all. You will be setting, since the final layer is 3 output, you go ask for 3 neurons with softmax activation to decide which is the maximum, and forward and backward propagation, this filter matrix values and all will be optimized. Okay, so this values is actually optimized in forward and backward propagation to update. Finally they would able to extract features and learn, and that's how CNN works. So first, are we clear with CNN working principle? Are we clear now? Can I get some response in chat box? Everyone, are we clear with this? So still you can convert the masterclass into 1 month certified internship on NVIDIA with AI. So when you join, you would be getting 30 days of recorded sessions, 30 days of PPTs, 10 exclusive project codes, VIP community group for doubts and internship updates, IETE internship confirmation letter, 90 days of access to our LMS course, assignments and tasks, weekly live sessions, resume building, mock tests, internship and participation certificate. All these things you could get at a discounted fee at 999. The registration link is posted in chat box, available in description. Internship batch 2 actually ends on 27th, so you could register and get all the benefits. 27th is the last date for batch 2. Okay, so now can we start by learning building a CNN with PyTorch? And I think Rajesh Patel, Mr. Rajesh, you have asked for formula, right? So if you want to calculate the CNN to linear layer, you have to mandatorily go with it. For example, if you know, I hope you know the height of your input image and width of your input image and the number of color channel, then you could go and substitute in this formula. So the height input plus 2 multiplied by padding minus height of your kernel with the kernel size, okay, the entire thing, okay, divided by stride plus 1 would be able to give you the height of your output image, okay. Input minus f plus 2 multiplied by padding, okay. Yeah, that's actually same, you can mismatch actually. So this is the same formula, height of your input plus 2 multiplied by padding minus the height of your kernel, which is your filter size, plus 1 divided by stride actually is important, plus 1 would be able to give you the output of your image height. The same thing you could apply for width to calculate, and see the color channel will be the number of filter you ask in your layer. If I ask for 32, I'll be getting 32 is the number of output color channel, okay. Are we clear with the CNN to linear layer calculation? Then for pooling layer, actually the formula is, if the output image will be input minus the kernel size divided by stride plus 1. And pooling layer don't do anything in the color channel, so they will be giving in the same way as your input channels. The width is also the same. Finally, for the flattened layer, the formula is height output minus width output minus color channel output flattens to a 1D vector. So this is the formula. Are we clear? Those who have asked doubt on this. Others, if you don't get it, please don't worry. We will be looking at it again when we come back. When there is a necessity, we will be looking at it, not now. Okay. So can we first build with PyTorch and then come for CNN with TensorFlow? Okay, I think you could take a snapshot of this. I personally use these formulas. It was really great and not confusing. Please work in the same order as well. Okay, height input plus 2 multiplied by padding minus of your kernel. Please take a snapshot. Later on you could use. It's actually a bit of confusion in the online as well. I searched a lot and able to get this particular formula, and it was reliable for me. I've used it in a lot of places, especially when I built GANs and all, generative adversarial networks with PyTorch. This was reliable, and especially when you want to go for TensorFlow, you don't need these calculations. When you want to go for PyTorch, you may need it. Note it down. Fine. So I think we could go and build a CNN with PyTorch, and for that I have kept my Jetson Nano ready actually. So let me connect it using SSH connection. Okay, so it has been failed. I think I have to just change the particular. Sometimes if you get this particular error and all, fingerprint error, what you could do is you could go into your C folder actually, users admin, and it is .ssh. Open the unknown hosts with a notepad and remove the particular IP, okay, of your IP. Just close it, and now let us try to freshly run this. It will be able to connect. Yes, password I'll enter. Yeah, we are inside our directory. So let me change the directory to master class. Okay, so we have untitled file anyway, so I'll go with Jupyter notebook hyphen port is equal to 8000 actually. And tomorrow we will be going with a project, so make sure you guys attend the session. We go with traffic sign prediction project. Can I open this in a new window? Can we continue now? Yeah, so here we are. Let me open a new file, Python 3 notebook. Yeah, you could use, for example, can I know what type of healthcare it is? Especially we could go for analyzing MRI, X-ray images using image processing, right? Mostly the results which is visual, we'll be dealing with it, right? I hope yours is also somewhat similar. All the best to your research. Yeah, so let us import Torch, import Torch Vision, and then mandatorily check torch.cuda is available. And that's actually a command. You have to actually use this true, so you can store it in device equal to CUDA if torch.cuda is underscore available. Okay, else we are going with CPU. So I am telling that if it is true, okay, so it will be storing device as CUDA. If you don't have, it will be just mentioning CPU. So now it is CUDA because we have it. Okay, so now what are we going to do is we will be creating a dummy CNN which we are not going to train now. Again guys, can you guys tell me in chat box, do I which will be better, if I use my Jetson Nano for training a model or if I use my Jetson Nano for inference? Which is actually a proper application of Jetson Nano? Can I get some response since you guys attended all these classes from introduction? It will be better if you guys post some answers regarding this. So will it be better to make just inference out of your Jetson Nano or even train it in your Jetson Nano itself, which huge amount of data? Yeah, if you go for training, there's a problem. Actually, this Jetson Nano has a limited memory. The RAM is 4 GB. The GPU is not that much great for training actually. So if you try to train, okay, it is just going to stop. When you train on image data, which is 60,000 images, 1 lakh images, it is going to just stop because it can't handle that much data. Okay, so you can go for high-end architecture. Okay, in such case. Or what else you can do is you could rely on cloud, or you could use your laptop with GPU, or you could go for Google Colab, anywhere where they go for GPU. Okay, you could use it to train a model. Okay, so when you train, you have to also recreate that your Jetson Nano has Python 3.7 version, and also what is the version of your TensorFlow, PyTorch you have to get. You have to mimic the same in another system where you could train with your hardware. Once you have trained, there are ways to save that model file. You could take it, it has all the history. You could take that file, place it in your Jetson Nano for inference. You can use GPU for faster inference. Okay, so that's Jetson Nano is edge computing. It is used for inference at edge network, not for training. You can do, but it will not that much efficient. Okay, so today we will see some demo of how to build actually using code. That's what we will be dealing now. But anyway, when we go for testing or inference, we will be using Jetson Nano. Now I am not going to train it here. Again guys, the batch 2 will be ending on 27th. You could still join and get all these benefits, code files, datasets, downloadables and all. The link has been posted in chat box. So let me continue now with, for example, as we know in PyTorch, we have to build a class. You can go for Google Colab actually for training the model, no issues. So as you guys know, we have to get torch.nn.module, right? So you have to inherit it. Then inside we could go for define double underscore init, double underscore self. Then we have to initialize the parent as well, which is going to be super CNN net, comma self, dot double underscore init double underscore. Fine. So let us create some layers. Finally we will be integrating. So let me go for self dot convolution 1 layer. So it is going to be a convolution 2D layer. This is the syntax, okay, con 2D with 1 comma 32 comma 3 comma 1. Okay, so what does this? Let us go and check our PyTorch documentation. Torch con 2D documentation. So please search this. You will be able to get the PyTorch documentation. So the first one is the input number of color channel. Okay. Actually, Jetson Nano has Chrome browser. You could directly open Collab there. You could work and download the file. Once you train it, that can be done. It's just running in cloud, right? So first thing is input number of channel. Next is output number of channels you want. Next is the kernel size. Then stride. Okay. And if you want other things, please mention with padding equal to 0 or 1 and all. You have to mention it. So as you could see the input. For example, this is a demo of a image which is black and white. It has only one color channel. These details we'll discuss in next session, and we have nearly 5 to 6 days for image processing. There we'll learn. If I have 3 color channel which is colored image, I will be going for 3. Okay, then 32 is going to be the output. I need 32 channels output after this convolution operation. Then what else do we have? The kernel size. I'll go with 2 comma 2, or you can go for 3 cross 3 and all. Finally, I have one here which is the stride value. Okay, so this is how I can configure. So this is first convolution layer. Then also I am not combining it, I am just mentioning them. Okay, so I am just defining them. So I have another convolution 2D that would have 32 as the input, because from the next previous guide would be getting 64 will be the output number of channel. Then same 3 comma 1 here will be. Then I will define a pooling layer. So the pooling layer will be nn dot. So we don't have nn actually, so we have to import anyway. From torch import nn. How are you trying to add TensorFlow GPU? Are you trying to recreate in Jetson Nano? Can I get information regarding it? So I'll get max pool layer, max pool 2D. 2 comma 2 filter and stride. Okay, so then self dot forward layer. Okay, convolution layer, I'll go with linear layer. This is for fully connected layer. Okay, so the size should be this. Finally will be providing you 64. Okay, so we'll be having a flattened layer, so it will be 64 multiplied by 5 cross 5 cross 128. And what is this 5 cross 5? This is actually calculated from the formula which I have shown here. Okay, so when we go into a project, I'll explain it detailedly. You could substitute and get these answer. Okay, so if my size of my image is 128, okay, when you substitute these formulas, we will be seeing in next class how to calculate. Finally we will be getting. Okay, so yeah, this is comma 120. Fine. For example, consider this scenario. Your input image is 28 cross 28. Okay, so if I'm having a height of 28 and width of 28. Okay, so first it goes through 1 comma 32 comma 2 comma 1, which you could adjust. Here we go for 3. Okay, so here you could try to calculate what will be the output of the height. It is height plus 2 multiplied by padding. Padding will be, if you don't adjust, it will be default 1. Okay, so it's optional, which means you have to research and experiment, hit and try, and then find which is best for you. Okay, so I'll also have a fully connected layer too. So PyTorch, especially when you want to connect from your flatten to this, you have to calculate this manually. At that we have to apply that formula which I'll explain, and then we go with linear. From this 128 it will be finally producing how many number of output you have. For example, if it is a 10 output or 3, for example, if it is a 3 multi-class classification 3 class, then we go with 3. So now inside forward, okay, so define forward, we have to inherit self and the x will be taken. So now we connect everything. So first x equal to, okay, So we go with self dot convolution 1. So I'll add my convolution layer 1 and the input is going to be my x. And after this convolution operation, we know that we have to apply ReLU. Okay, so I'll go with torch dot ReLU layer. Okay, and after ReLU we know that we have to apply pooling layer. So I'll go with self dot pool here. Got it? So input convolution layer, ReLU, then pooling layer is done. So this completes one set. Then I add the same block again. Okay, so here I'll go with convolution 2 now. So you have done 2 block of process. Next I'll go with torch dot flatten layer. I'll go with x comma 1. Okay, flatten all dimension except the batch, so you get flattened. So once this has been done, I go with x equal to torch dot ReLU of. I am applying ReLU to the FC1 output x, and then the final layer will be torch dot ReLU of. Okay, for example here we will be just applying, because we will be using softmax later on, so FC2 of x, and then finally we just return x. Okay, so this is how we go in our formula. So here we went with 1 comma 32 comma 3 comma 1, right? So let us do now one thing. One is the input channel, so let me type in comment height input equal to 28, then output. Okay, so that is channel input equal to actually 1 here. Then we calculate the channel, stride equal to padding equal to we get now. Okay, so kernel is actually 3 here. Then stride is 1, padding 0. Okay, stride 1, padding 0. So these are all the things which we have. So now we are going to substitute this in the formula here. Okay, so height input plus 2 multiplied by padding minus kernel. It's 2 multiplied by padding minus kernel size, right? So here the kernel height of your kernel is going to be 3. Okay, so in this particular thing, the next step is you would be also going for divided by stride plus 1. Okay, so what is divided by stride value is 1, the entire thing plus 1. So this is the height output of your image. So let me try to calculate this. The 2 multiplied by 0 goes to 0. Okay, so minus 3, so it is 25 divided by 1 plus 1, so the answer will be 26. Okay, so this is the height output of this particular channel. Got it? So this applies for same the width as well. So likewise we will be calculating and finally getting it. Okay, we will do it especially in our padding, or else we will just continue. For example, anyway we got 26, right? So after this 26 is your output now. After convolution 1 you get 26 cross 26. Initially it was height is 28, width is 28, consider. So the output now will be 26 cross 26. From here I need to apply max pool 2D layer. So what's the formula of max pool 2D? Height input minus kernel divided by stride plus 1. Okay, what's your height input, which is 26? Max pool 1, height input is 26. What's the formula? 26 minus kernel size minus 2 divided by 2, entire thing plus 1. And it is 24 divided by 2, which is 12, and the output will be 13. So after this first operation entirely, the output of your image shape will be 13 in height multiplied by 13 in width multiplied by single color channel. This is single color channel, but here you have asked for, here it will produce 32 is the output channel. So this will be the output shape of your first layer's image. So from here you need to substitute the same formula again, which is 13. Okay, plus 2 multiplied by 0 minus 3 divided by 1, entire thing plus 1. So this goes to 10 plus 1, which is 11. Okay, so with this 11, if you apply in the max pool 2 layer, when you imply, it is going to be 11 minus 2 divided by 2 okay, plus 1 entirely. So all these things divided by 2. So that is 9. Okay. Here actually it is 13 minus 3 is 10 divided by 1. I think we made some mistake here. Okay, so when we imply this here, it is 11 minus 2 will be 5.5 plus 1 will be 6.5. That is not correct. Height input minus kernel size divided by stride plus 1. Anyway, we'll recalculate and come back to this. Fine, we'll look at it later, and before completing we also need to build with our TensorFlow, right? So for example, okay, fine. So we'll try to recreate the same CNNs in our TensorFlow. So for that we have to import TensorFlow as TF. And when we go for TensorFlow, actually the task is pretty much simple. So here we go and import all the layers, right? So from TensorFlow layers, okay, this is TensorFlow.keras. We import layers, comma, sequential. Okay, so as you know, you could go for model equal to sequential, and then we could go for model dot add. So first I'll add layers dot convolution layer. Conv2d is the particular command, and here the first is the number of output neurons you want. I want 32. Then filter size here we mention as 3 cross 3, something like this. Then the next thing is the activation function. I go with ReLU, and then the input shape. So input shape should have an extra dimension which should match something like, for example, if it is 28 cross 28 with one color channel, it should be in this way. Okay, so this is the first layer. Then I will be adding model dot add. I will go for layers dot max pool 2d. So we go for max pooling 2d layer, and yeah, here we will be mentioning 2, 2, which is the kernel size. Okay, then we will be doing another stack of it. Okay, so here I want 32, right? So here we don't need to calculate them, they will be automatically done. So we go for 64. Here don't need to pass the input shape actually, so I have to just mention the activation. Once this has been done, you could add a flatten layer. So you could add for flatten layers dot flatten, simple. Okay, layers dot flatten. So once flatten has been done, you could go for model dot add fully connected layer. So layers dot dense. For example, I want 128 neurons here, so the activation is ReLU. Then finally I'll add output layer, which is model dot add layers dot dense. I need to classify between 3, and the activation is equal to softmax. So remaining compilation and all will be same, no issues. Okay, same like our artificial neural network. So we will do in the same way to build on TensorFlow, and then we train a model, and we will be implying this practically in the next session, where we will be implying this. Clear about this? So if you guys are clear, please wait. Let me just sort this particular doubt here, which we had. Actually here it is not, the calculation is not matching. the input is 28 plus 2 multiplied by 0, entire thing goes to 0, minus 3 would be giving you 25, the entire thing plus 1 will be 26. This is correct. Then I go for a max pool layer, which is the divided by 2 minus 2 divided by 2, so that goes 26 minus 2, which is 24 by 2 is 12, 12 plus 1 is 13. Here we have it. And when you go for 13, this is your output. From this we would go for again the set of layer, minus 3 divided by 1 plus 1, 13 minus 3 will be 10 plus 1 will be 11, and when we apply 11 here, it is 9 by 2. Yeah, so here it is 9 by 2 plus 1, which is going to be approximately, it should be 5, around 5, right? 9 by 2 will be 4.5. We will be going rounding off, plus 1 will be 5.5, around 5 will be there. I will just check again, okay, and update you guys regarding this in the next class. And that's why we went with 5 cross 5. Actually I tried to train, it was working, but it hanged during the problem because Jetson Nano cannot be used for training. I will check it and update, okay, especially regarding this. So this 64 is the output from here, so we go and get it in this way, okay. I'll check and again I'll update. So I haven't planned for this anyway. We'll check and update. So that's it for this session. Thank you guys. The attendance link has been posted in chat box. You could get and finish it. And also you could join for batch 2, which ends on 27th. By this weekend you could get all these things at a discounted fee at 999. The link has been posted in chat box. You could register and get benefits. Thank you all. Thank you.